Good morning to all of you again. We have just looked at what are the sampling designs, specifically random sample designs, non-random sampling design, and mixed sampling design. Today, let us look at how to determine sample size. We have just seen sample size and sampling in this unit. We're still in data collection unit, and we still have data collection and data analysis to be done. So in data collection, we'll be looking at what are the instruments that we need to use, starting from the plots, the transits, different kinds of instruments. Then what are the procedures to use these different kinds of instruments. Today, let us look at what is sample size and how to determine sample size. So one of the frequently asked question is, how big a sample should I select? What's the number of samples that we need to select? Another one of the frequently asked question is, what should be my sample size, or how many cases do I need to select from the population? So let us now look at ways to determine the sample size. Whenever you're dealing with the sample size, what you really need to look at is you need to look at the purpose. So sample size really depends on the purpose that we are undertaking. If our purpose is something that really needs high accuracy, then our sample size should be high. If a purpose is something that we really do not want to look at very high accuracy, it's not a very specific kind of research, it's not in-depth research, it's just knowing a general view, a general idea of something else, then the level of accuracy will be less, and accordingly the sample size can be less. Again, it depends on whether the approach is qualitative or quantitative. If it is qualitative, the sample size phenomena is not that important. Unless you reach data saturation point, you are collecting the sample of your choice. But if it is quantitative, then you really need to determine the sample through some sort of formulae or some sort of some other procedures we should be looking at in a while, and then you need to choose more if you need more accuracy, and if you need less accuracy, choose less. So it really depends upon the purpose and the level of accuracy. General rule is that if you feel that your sampling population or the population is diverse or it's very heterogeneous in nature, then in that case you need to select as many samples or as many respondents or sampling units as possible to increase your level of accuracy. But in case if you are choosing more or larger sample size, please note that your accuracy will also be large, or your accuracy will also be high, or in other words, they will be more accurate. Larger the sample size, higher the accuracy, and the more diverse the population, the higher number of samples that you need to take. If you look specifically now to determination of sample size, there are two factors that will affect the number of samples that we choose. First one is the level of confidence. So the level of confidence here is whether you are looking at your results, findings, or hypothesis through 95% of level of confidence, or 99%, or 100%. So that's on you again. So if you really need a high level of confidence, you again may want to choose more number of sample size. The degree of accuracy again is the second factor that affects the sample size. If you need a higher degree of accuracy, more sample size. And the last one is the level of variation. So that's nothing but standard deviation. if your level of variation is very high in that population, or the population is very heterogeneous in nature, then you need to again choose higher sample size, and vice versa for all the three factors. So again, it really depends on factors like time, budget, and other resources like skill and manpower. So if you have less time, for example, the formula used, which is the next slide, the formula to be used to calculate the sample size, if you use that formula, and if that formula gives you around from the population of 2000, if it gives around like 600 people as your number of respondents, or if your sampling area from the formula results in around like 4 to 5 hectares, then most of the cases in dissertation or thesis time, because you're just allotted with 6 to 7 months of data collection as well as data analysis and report writing time, in that case it will be quite difficult for you to do the sampling of this huge number of respondents, or the sampling of this huge area. So in that case, you again need to adjust your sample size. Again, that again depends on the time, again budget here, and other resources like skill and manpower. You really need your friends, you really need someone to help you out during your data collection. So if your sample size is quite very huge and you are the only person, or you just have 1 to 2 helpers or field assistant, in that case again you may need to again revisit the sample size. But whatever it is, there are 3 factors that will determine the sample size: level of confidence, either it is 95% confident, or whether it is 90% confidence, whether it is of 99 confidence interval, or the degree of accuracy, and the level of variation or standard deviation. So let us try to look at one example. So suppose in a class you want to find out the average age of the students with an accuracy of 0.5 of a year. That means let's say 41 from 40th to 3rd year, you're going to look at the average age. So let us say that I'm basically trying to look at the average age of the class from 41 of you, and I wanted to choose a number of samples to do this research on average age. So in that case, the accuracy that I want is 0.5, or the margin of error that I need is 0.5. So what I mean is that, for example, let's say, for example, the average age of your class may be 22 years, and I do not want the error to be less than 21.5 and more than 22.5. So 21.5 is lower bound of my error, and 22.5 is the higher bound of my error, and 22 is the actual age that I want to find out, and I do not want to have the error more than 0.5 plus minus. So that's accuracy. Then second one is that I want to calculate the average age looking at 95% confidence interval. So in that case, provided you have got 2 things, one is level of accuracy, or you can say the error, and the other one is 95% confidence interval. That's the level of confidence. So a third one that we need, the level of variation, is not reflected here. So we'll just be looking at how to determine by just having these two things. So if you have 3 things, then we can determine it easily, but the third thing can be generated. We'll be looking at it in a while. The formula to determine the confidence limit through any statistical books or any statistical reference is the population mean equal to sample mean, and this t value 0.05 is for 95% confidence interval, and we have got standard deviation, and then we have got under square of the sample size. So basically this is population mean over here, and this is sample mean or sample average, and this is t value 0.05 at confidence interval of 95%. So 95% confidence interval means you have just 5% to be not confident. In other words, it's 5% is basically 5 divided by 100, so that's basically 0.05. So 0.05 is actually that's something else which is here, and this sigma is nothing but the standard deviation, and this is the square root, and this is the sample size over here. So we have everything in this formula. From this t 0.5 to sigma divided by under square of under root of square root of sample size is basically, this circle is basically standard error. So you can also say simply error. So this is error. Then we already know that the error that we need for our calculation of average age is 0.5 years. So that's our error. So we'll just replace the error here. So if you say that this is the marginal error or the standard error or just an error, then this, if this is equal to 5, then in this formula we can replace, in this formula we can replace 0.5 with this one. So we just have simple mean and the margin of error here. So in other words, if this is equal to 0.5, then we'll just not look at this one for a while right now. We'll not look at these things here. So if this is 0.5, then we can also basically see that sigma divided by under root of n is equal to sigma divided by under root of n is equal to 5. So this is t 0.5. So we can also see like this, right? So because this is margin of error and this is what margin of error that we have. So if this is equal to this one, then t 0.5, the level value of t 0.5 is basically 1.96. So 1.96 into sigma divided by equals to 5.5. So I hope you got this one. We're just playing with these two things. We just forgot these things, the sample mean and all. So we're just replacing 1.96 into sigma divided by underscore square root of sample size equal to 0.5. Then if you just bring the square root of sample size over here, then we are just left with 1.96 into sigma divided by this 0.5 we just took pin it over here. So this is how we find out, and this we can solve. What we can do now is, since we have got square root here, to cancel this one, we can take it here, but overall this can become square if you have to cancel this one. So sample size is basically equal to 1.96 for 95% confidence interval into standard deviation divided by 0.5. That's a marginal error. So in this formula, what we can see is that the sample size is inversely proportional to the margin of error. That means if you have to have a lower sample size, lower sample error, or lower margin of error, or lower standard error, like let us say 0.4 is lower than 0.5, then we need to increase the sample size. If you have got higher standard error, then we can have lower sample size. So that means if you need your results to be very accurate, that means if you really need your results to have less error, then we need to increase the sample size. Other thing that we can also realize from here is that the confidence interval value here is again proportional to sample size. That means higher the confidence interval, if you're taking from 95% to 99% confidence interval level, then again we need to increase the sample size. That's proportional. So the confidence interval and sample size is again proportional. Again, another thing that we realize from this one is that sigma, or standard deviation, is again proportional to the sample size. So higher the standard deviation, higher the diversity or heterogeneity, higher the sample size that you need to take. So sigma is something that we did not or could not find in our study over here, and sigma is very difficult usually to find out during any kind of study, because you do not really know the population that you're studying. In case of population that you have never counted, or you cannot count that population, or you're not sure about that population, so in that case sigma is quite difficult. But if you already know the population and some basic characteristic of population, sigma can be found out. But in case of a situation where you do not know anything about the population or any characteristics about the population that you want to find out, sigma is quite difficult to know. But you can generally find sigma by guessing. For example, okay, that population may that class may have average height, average age of around 21, and some people are in service. So some people are in service, so maybe they are 5 years old, 5 years older than the general students, and some students are just 3 or 4. Some students, the youngest students, are around let's say 18. So around I can have standard deviation of, I can calculate the standard deviation from here itself. So you can basically guess. Sometimes you can consult an expert who has already done such or similar research in that class or in that field. Sometimes you can get the standard deviation values from previous comparable studies. Same studies must have been done in that area, but not exactly on the age. So you may get some information from there. So try to get information from those comparable studies. And you may also want to go out to do some pilot studies, feasibility studies, do some reconnaissance studies, and you can get some basic idea about how is that population, what are the basic statistics about that population, and you can basically calculate the sigma. And from from these 4 ways to determine sigma, let us say that I have somehow managed to get the standard deviation value as 1 year. That means in forestry year 1, by year 3, it can either go till 23, or it can either go till 21. That's the standard deviation, or that's the variation. So I just saw that it's 1, and I replaced 1 over here. So 1.96 into 1 divided by 0.5. Then I got this one. So if we got 3.92, then I have to cancel this one by taking square over here. So square of 3.92 is basically 15.37. So if you're looking at some definite population, then you may want to round it off to either 16 or either keep it to 14, because people or person or respondents cannot be in decimals. So I can take 16 in order to have my study through 95 confidence interval and a margin of error of 0.5 years. let us say that if you are increasing margin of, let us say if you are increasing the confidence interval by 99% from 95%, then with the same formula and same margin of error, I took that the t value of 0.01 is basically 2.576, which we just got from here. So 99% means we're just leaving 1%, and basically that 1% is basically 0.01. So the level of 0.01 gives t value of 2.576. So 2.576 is here, and the same formula applied over here. Then we got square root of n is equal to 5.15, and we just take this square over here. Then we got 26.54. That's equal to 27. So what we see over here is that, like I said, higher the confidence interval that you want to look at, higher the sample size you need to take. So the confidence interval that we just took here was 95, and we got 16 as our population, but we increased to 99 over here, and we got 27. So higher the confidence interval, higher the sample size. And again, if you want to you can change the margin of error by, let's say, 0.1 year, then imagine that 25.576 into 1 divided by 0.5 was giving this much, divided by 0.1 may give again very less as compared to this one. So again, the number of sample size can be increased. So higher the level of accuracy that you are that you want, then the higher sample size. So use this formula to generate your sample size, because this formula takes into consideration of standard deviation, level of accuracy, as well as confidence interval. But there are different ways to determine the sample size, and let's look at the different ways to determine the sample size. If you do not like that standard formula that you just saw, so if you have a population, let's say a very small population of 200 individuals or 200 respondents, or a very small study area, let's say you are just looking at 1 hectare study site, in that case I recommend you to take the census survey, or surveying all the respondents, because if you survey all the respondents, your margin of error or standard error will be comparatively low. So if you are looking at this small sized population, always take always take all the population as your sample. That's also known as technically known as census. But if you're using the study site that's being applied by some other researchers, or that's being studied by some other researchers, then you can always take the sample size that's being reflected in that research or in that article. Or if you are looking at similar study done in one part of the place, or one part of the country, or one part of the region around the globe, and that similar study you want to replicate, because research is all about reliable and validity. So you can basically replicate, and you can also replicate the sample size. So for example, from 1 hectare, they must have taken 1 hectare temperate forest in Brazil, I don't know, in like Germany, let's say, then to study regeneration. Then you can also take the same sample plots in Bhutan in temperate forest to generate that same kind of results. So similar study can help you out. You can also use published tables. For example, the research advisors, like I'll show you in a while. This is called as research advisor. This is already published table. So this table shows the level of confidence at 95 and 99%. Usually 95 is being used in our research, but if you're looking at a very high-end, accurate research, then you may want to go with 99%. Let's say if you're if we are using 95% confidence interval, and let us say that the margin of error that we are accepting is 5%, margin of error that we are accepting is 5%, or 5% or 0.05, then if the population size is 10, then you have to take all the 10. So because the size is very small, and if you take 9 from the 10, then your margin of error will be high. Let us look at here. Even for 30, you have to take 28. But if your margin of error is 1%, then you have to take again all the 30 here. So can you see the difference here? So only for 75, if your margin of error at 95% confidence interval and 1% is 74 out of 75. So that's your sample size. But if the sample size, if the population is around 1000 at 5% margin of error and 95% confidence interval, you have to take around 278. And similarly like that, if your margin of error is very less, then we see that the sample size is inversely proportional to the margin of error. Then again, 906 is the sample size. So let us say that the population is 5000 and the margin of error that you need is 2.5% at 95% interval. Then you need to take around 1176 people. But let us look at the same thing here. 5000 is the population and the margin of error that we need is 2.5%. We need to take around 1734 people here, which we just took 1176 here. So again, higher the confidence level, higher the sample size. So that's basically something that we get it from the research advisor. Again, these are based on these are backed by research and formula. So you can also use research advisor. In case of if you do not want to use research advisor or like published tables, you can also use formulas like Yamini formula or concurrence sample size formula. So Yamini formula is this one. So n is basically sample size is equal to population divided by 1 plus population into the error square. So let us see that we want to do a research on how CNR staffs and students are using the computer as work. Then if you see that in total students and staffs we are summing up to 2500, then at 95% confidence interval, what is the sample size that you need? So it's basically 200 divided by 1 plus 200 into, if the margin of error is, let's say we need around 0.05 square. So from here you can basically find the sample size. This is called Yamini formula, but mostly applicable to the population more than 1000, and if it is less than 1000, then you do not want to use a Yamini formula, because the margin of error that it may arise through its formula may be quite high. The last one is online sample size calculators. There are lots of online sample size calculators now, so you can use any one of them. Just type sample size calculator and lots of things will come out. So just go online and calculate the sample. But whatever formula or whatever table or guide you're using, just keep three things in your mind. You need level of confidence, 1. You need degree of accuracy or precision of margin of error, and you need level of variation to take into consideration in your study. And also note that sometimes you do not know what sample size to take, what formula to use, because um, uh, study population or study area may differ from one person to another person, and in that case you may also want to look at census survey if it is less. Then if it is not less than one, if it is not more than 1000, or it is just more than 200, like let's say 250 or 300, then again if you can, then you can take census survey, or if you cannot, then you can also go and stick with the 50% sample size. So if it is like you have around 500 population, then you can always take around 250 respondents as for your sample size. So that's it on how to calculate sample size. And in natural science, you may have to lay out plots, transects, and all. And on that, we will be dealing with the data collection instruments and procedure part. So please do not get confused. This is all about sample size, and in natural science, whatever thing that we're using, like plots, sample size, transects, quadrates, plots, and all, we'll be looking at it in detail when we are studying data collection. So thank you so much on this one.